Hey guys, welcome back to the laboratory. In this video, we are looking at the development of the modern periodic table. By the end of this video, you should be able to describe how elements were arranged in Mendeleev's periodic table, describe how elements are arranged in the modern periodic table, and identify similarities and differences between Mendeleev's and the modern version of the periodic table. So, let's go. The modern version of the periodic table is widely used across the sciences. It arranges all known chemical elements into rows and columns and is read like a book, from top to bottom and from left to right. A row in the periodic table is called a period, and a column in the periodic table is called a group. The history of the periodic table was vast, and its arrangement to date is far more in depth than what first meets the eye. The table as we know it today is largely influenced by the work of Russian scientist and inventor Dmitry Mendeleev. When establishing how best to arrange the elements in his periodic table, Mendeleev noticed that the elements displayed patterns in their chemical properties at regular intervals. Each time the pattern restarted, Mendeleev would create a new row, and it was this approach that led to the arrangement of the elements into periods and groups. Mendeleev's version of the periodic table would have looked something like this, and at first glance, we can already see the genius in his method. At the time Mendeleev conducted his work, the electron and the proton were yet to be discovered, and so Mendeleev arranged his table in order of increasing atomic mass. Elements in the same group shared similar chemical properties, and Mendeleev would swap the positions of different elements if he felt their properties were better suited to the elements in a different group. In some cases, Mendeleev was unsure of where to place an element, and so it would appear in the table twice. He would also leave gaps in his table for elements that were yet to be discovered, and he made predictions about their properties based on where they were positioned. What was most incredible about Mendeleev's work was that the elements he made predictions about were later discovered, and with the properties that he predicted them to have. With Mendeleev's version of the periodic table side by side with the modern version, we can easily spot the similarities and differences between the two. Let's start first with the similarities. In both tables, elements are arranged into groups and periods. Elements in the same group share similar chemical properties, and in both tables, metals are found towards the left-hand side and non-metals are found towards the right. In contrast, the modern periodic table contains far more elements than Mendeleev's, including the transition metals and the group 0 elements. Mendeleev arranged his periodic table in order of increasing atomic mass. However, the modern periodic table is arranged in order of increasing atomic number. And finally, there are no gaps in the modern periodic table, unlike Mendeleev's. So, visual learners, you might want to pause the video here and make a note of this Venn diagram or snap a picture of it for your revision notes. Don't worry, you know I've got you. Understanding how to read the skeleton of the periodic table is a required skill at GCSE level, and it will be of great help to you in later topics. So, for example, letter X will have the lowest atomic number as it's at the top left of the periodic table. Letter J will have the highest atomic number as it's at the bottom right. Letter T is a metal as it's on the left-hand side of the periodic table, whereas letters Y and G are non-metals as they are to the right. Letters Y and G will also share similar chemical properties as they are in the same group. Here's an example of an exam style question that you might be asked on this topic. Pause the video, read the question and take your time to answer. I'll be waiting for you on the other end with the mark scheme. For question 1A, elements G and L are both in the same period. Elements in the same group will have similar chemical properties, so the answer to question 1B is T and J. Elements to the right-hand side of the periodic table are non-metals, so the answer to question 1C can be letters L, T, or J. And finally, as the periodic table is read from top to bottom and from left to right, the element with the highest atomic number is letter Q. So, how did you do? Let me know in the comment section below. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!